So today we're doing a decay function. These are exponential functions again. They're exponential because the variable is right here at the exponent. Okay. And this should say 1/4 to the x equals y. We'll make that an equal y. All right, but how do you know that this one is a decay? So this is a fraction, but this is a growth function. No, these are all equations. They all have to be equal to something. Okay, so this is a value greater than 1, isn't it? Isn't 3/2, which is a fraction greater than 1? So when your base, remember this is your base, falls between 0 and 1, so it's a fraction, but it's a fraction less than 1, then you have a decay. So look around the board. These are all growth functions because they start small and they get quickly very large y values. Okay? These are going to be decays. Now we're going to treat them the exact same way. We know that our domain is going to be that x is going to be equal to the element of the reals because x can be any value. All right? Let's see what happens to our y's. We'll do a little chart. I want you to do both a positive, negative, and 0. So if x is -1, I'm going to say that y will equal 1/4 to the -1, correct? What's 1/4 to the -1? Which is 4. So x will be 4. If x is 0, what is y? Well, it's 1/4 to the 0, so 1. Anything to the 0 is 1. And if x is +1, we're going to get 1/4, correct? Does that make sense? So what do we know from yesterday where to find our asymptote? It's where? It's what you're adding or subtracting out to the side. And if nothing is there, then we know that we are 0, okay? So we're going to go ahead and we're going to put our little asymptote right here at 0. Well, probably. Let's see what happens, because isn't that what's happening? Isn't our range greater than 0? We're never getting negative values, right? So at -1, we are at 1, 2, 3, 4. At 0, we're at 1, and at 1, we're at 1/4. So see how now our graph comes down and approaches our asymptote but never comes in contact with it? Instead of going off into infinity, it's coming down. So yes, y will be greater than 0. Not equal to, because we'll never get to that value, strictly greater than. Okay? All right, so we know that this is still a decay because we're dealing with 1/4. What's this negative sign going to do? Where is this graph? Look over here. Where is your graph going to fall when you got that negative? It'll be below, so you'll be graphing below the asymptote, right? Uh-huh. Well, 1 to any power is just going to be 1.
Wait, so like if it has to be a fraction though, right?
Mm-hmm.
So could it be like 2/2?
Because a reduced fraction less than 1. Okay, Pooja? Yes. Well, the negative sign tells us where we're going to be, above the asymptote or below the asymptote. So we're just looking at the base, just the number itself, yes. Okay? Okay, so that means x is an element of the reals. In this case, y will be less than 0 because we're falling underneath our asymptote. And so our little chart, when x is -1, we're going to get -4. When x is 0, we're going to get, what do we get? negative 1, because that negative sign is not inside the parentheses. It's not getting raised to any power. At 1, we're going to get negative 1/4. So our asymptote, again, is right here at 0. And at negative 1, we're right here. At 0, we're here. And at 1, we're here. And so this is still, while it looks weird, it's still considered a decay function because of the fact that our base falls below 1, the value of 1. Does that make sense? Does that make sense? So you've got a quiz coming up, all right? And one of the things that I will ask you to do is just looking at the function, is it a growth or a decay? And why? You'll have to tear it apart and tell me what's telling you that it's a growth function or it's a decay function by looking at the equation. Okay? All right. So, base is 3/4. Growth or decay? 2. Falling above or below the asymptote? Because it's positive. So our domain x is an element of the reals. Range y will be greater than, in this case, 0. Because if it's going to be above, our range is determined by where our asymptote falls. And our asymptote is determined by what we're adding. See, but there's a pattern. So we know that because we're going to be falling above our asymptote, our values will be greater than 0. Versus below our asymptotes, then our values are less than 0. Putting it all together? Okay. So do our little XY chart. It's always a good idea to know what in your mind this is supposed to look like. Kind of an extra validation as you get your chart if you've made a math mistake. So at negative 1, I'm going to get 2 times 4/3, which is 8/3. At 0, I'm going to get 2, right? Y'all with me on this? And at 1, I'm going to get, or also known as, 3/2. I got 8/3 at negative 1 because I'm going to flip the fraction 3/4 because it's got the negative exponent. And we're going to put a asymptote here. And we're going to plot our points. And we're going to say at 1, we're at 8/3. That's almost 3, correct? At negative 1. And at 0, we're at 2. And at 1, we're at 1.5. And so, yes, it comes down, sloping down. How we doing? Good? Let's do one of these over here. This one was actually +2 over to the side. I'm not going to graph both of these, but let's just talk about these a little bit. I think we're okay with graphing these, aren't we? Are we okay with these? This is a decay because of the 1/2. This is above or below the asymptote. And we know that because of the, there's a bunch of 2, so it's because of this 2 right here. And we know our asymptote is what? Nope. Y is greater than 2 is my range, but my asymptote occurs at what value? Y equals 2, right? And your range is greater than that value or less than that value, Rachel. Haley, is this making sense? Okay. Here, above or below the asymptote? Above or below? A blub? What's a blub? So, Rachel, above or below? Okay. Asymptote at? Yeah. Domain x is an element of the reals, and y is then? Correct. Okay.
So like when you're graphing it, just because the exponent is like x plus 2, it wouldn't be any different. It would just like you have to.
Yeah. You will just put when x is 0, or let's say negative 1, it's going to be 2 times 1/2 to the first, right? Negative 1 plus 2 is 1, and then minus your 3, whatever that value would be. Okay, So let's tear this apart and do this for every function now. We did this yesterday. A determines if you're above or below your asymptote. So if A is less than 0, where are we? Below, because that means it's negative, right? What the heck, I can't spell. Below. And if A is greater than 0, then we know we are above the asymptote. So we're negative here and we're positive here. B is our base. If B falls between 0 and 1, is it a growth or a decay? If B falls between 0 and 1, it's a decay. But if B is greater than 1, we have a growth, like 3/2 or 7. Are we good? H. H is just our growth. It's part of our growth factor. It just makes our graph grow up or down faster. And K, what does K determine? Yeah, it determines the asymptote and therefore also what? The range. This board is acting really weird. So our domain will always be X as an element of the reals. And our range, Y will be greater than K when A is what? Or, yeah, when A is? Yep. Y will be less than K when A is less than 0, right? Is that making sense? How we doing? Does this make sense? Okay. All right, so here we go. So, you know, our formulas yesterday were about growth. So we added our rate. Well, this one is now about decay. How do you know that this is a decay? Because you are subtracting your rate. So while I'm telling you you've got two formulas, you really don't. You have one formula. You just have to know how to apply it. If I have a growth, I'm going to add R. If I have a decay, I'm going to subtract R. Give me an example of a decay in real life. What decays quickly or slowly over time? Okay. And that can be a quick or a slow decay. All right. But there's something that we use all the, not we use, but that occurs in nature. And you've heard about this as a decay. Okay. So fossil fuels. I'm thinking plutonium, uranium, any of those radioactive materials. They have a decay rate. That's why they're so hard to get rid of, because they don't just disappear. They have something called a half-life, where if you have 1,000 pounds and it takes 1,000 years, you're down to only 5,000 pounds or something like that, or 500 pounds. Okay? So a decay means how quickly you can get rid of it. Yeah, I mean, there's like, okay, like for example, the cost of a car, as soon as you roll it off of the car lot, it decays in value, it lessens in value, and it doesn't lessen like $500 every year. It really decays quickly for the first 3 years, and then just kind of it goes down in value, but not quite as quickly. So that's why some people think, well, I'm never going to buy a used car or a new car, because as soon as I roll it off, I've just lost $5,000 of the value. So I'm going to buy a car that's maybe about 3 years, because that's when the decay doesn't happen quite as quickly. So. All right, so A start is your initial amount. R is your rate, and how do we want to write it? As a decimal. And T is over time, whatever your time is. 5 years, yeah, so this one's 5. So you buy a car full, not 4, but full, $5,000. That's what we start with, or 50. It decreases by 12% every year. That means it's 1 minus 0.12. How much is it going to be worth in 5 years. So you're going to go 1 minus 0.12. Get your calculator out and do it. 1, remember you work with this whole parenthesis mess first. 1 minus 0.12, get an answer, raise it to the 5th power, get an answer, multiply it by 50,000. Meg? I was asking you what your rate was. So in this case, you would add it to figure out. So if I would have given you your growth factor or decay factor is 0.88, then you would need to add what is equal to 1 minus what, basically?
So you can probably get
Mm-hmm. Does that make sense? 1 minus r is equal to 1.88. So you would realize that that was 0.12, which is 12%. Oh, gosh. So what is this about? So it's approximately $26,000. So if you think about it, over 5 years, you've just lost half the value of that car.
I never knew that.
Yeah. Cars do not hold their value very well.
Why is it that when they get when you buy them, they get less?
Because they wear out. You can't use it indefinitely. A house you can use indefinitely. So over time, depending on where you live, it grows in value. Some people look at it as an investment. Some people look at it not as an investment because you're always owing money on it over at least 30 years. But when things, I mean, you can't use a car forever. It just wears out. It becomes more expensive to replace the parts than it does just to get a new car.